I'm here. Diraj is signing in now. I'm sending a message out to all the attendees.
Diraj
Hey,
is
everybody.
Hi everyone, welcome to the DevOps.com webinar, Accelerate Your Serverless Journey with Splunk and AWS. And today we have a very exciting panel with us. If you have any questions during the webinar, please feel free to utilize the chat section, which is available on your right-hand side window. And our speaker will be able to take that questions as well. And also, this session is being recorded, so you can also view the session later on demand as well. So with that note, would like to hand over to Corey now. Once again, a very warm welcome to you, Corey.
Thank you very much, Diraj. And it's a pleasure to have everyone joining us today. So my name is, I'll just change slide here. My name is Corey Harmon. I'm an observability strategist with Splunk. I've come from a background of consulting. I've been an end user. I've kind of been through the traps. Worked with every sort of industry, all sizes of clients, all the way through from big data, machine data, you name it, into now the observability space. So, and then we've also got with us today Ashneet from AWS.
Hello everyone, how are you guys doing? My name is Ashneet Gujral. I'm a partner solution architect at AWS, and I support Splunk in a lot of their go-to-market activities and ventures. And really interested and kind of excited to be here to talk about serverless and a lot of fun things. So with that, let's quickly get into the agenda and get the conversation going. All right, so our agenda for today, fairly straightforward. We're not gonna go around the bushes, but we're basically gonna focus around, why are customers adopting serverless first strategy? Then we're gonna go over the serverless journey, as well as then at that point, Corey will take over and talk about some of the operational challenges of serverless itself, as well as Lambda extensions, which really enable you to kind of take advantage of observability aspect of Splunk and serverless, and how does that work, and eventually end with a demo. So with that said, we're gonna do a quick poll to kind of get everybody going. So if you can get the poll going.
Hopefully the poll has been pushed out to everybody.
Yep.
We'll just give you another couple of seconds to answer the question. And then we'll go straight into it.
Okay. All right, do we have results for the poll? Let's see.
We have some great answers coming through. Well, we've got a good mix by the looks of it. Good mix of roles today.
All right, cool. So we have SREs, architects, and a couple of others. Surprise, not a lot of security analysts and developers, but it's all welcome. So it's all good. Cool. All right, cool. All right, let's get started. Let's see how things go. If you go to the next slide, okay, let's talk about what really our customers need to kind of drive success. When we talk about this to different folks and different customers, we're always talking about going to market first. You want to lower your total cost of ownership, and you want to be able to scale and deliver performance. And on top of it all, with everything going on, you want to be secure and be isolation by design from that perspective. Those are some kind of key ideas why what really drives customers to success. And if you go to the next slide, we'll kind of have a quote for a CIO that talks about, 80% of their developers spent their time basically doing operational and maintenance of the application. Only 20% of that time is actually spent on innovation. That's really kind of interesting to kind of look at it from that perspective. Is saying, hey, when we talk about average life cycle of application development, you can even associate that saying 80% of that is just kind of doing the basics, just establishing the foundation, spinning up a like Apache server or Nginx server and kind of managing that. Who likes to do that? Developers certainly don't. They kind of have to live with it because that's what they kind of live in that space. But about of all of that time, only 20% actually spent to actually innovating there. So we want to kind of change that. And that's where serverless comes in. If you go to the next slide, um, serverless uh, has come on and is growing extremely fast. It's adopted by a lot of customers all over the place. We have at AWS, we have hundreds of thousands of customers who are taking advantage of serverless, and on average, month, you're looking at trillions, if not more, Lambda execution per month. That is the scale of it is unbelievable. If somebody were to try to do that on kind of a traditional architecture, that would never be possible. With Lambda, it's just unbelievable how quickly you are able to scale. So looking at the next slide here real quick, see if that slide comes up. Yep, here we go. Serverless really much more than what everybody thinks. It's much more than commute. Every single time customers look at serverless, they're always thinking about just like a Lambda, like a web application, something along that line. Nowadays, it's a lot more. You have the compute layer, which is kind of the Lambda and Fargate, but now, excuse me, you also have to think about the data stores. People don't realize this, that S3, Amazon S3 is a serverless service. You're not maintaining servers, you're not managing it. A lot of the databases like Aurora Serverless and DynamoDB are also serverless because you're not really involved in the day-to-day operational management of those infrastructure. You kind of say, hey, I want this, and you start using it. In the case of S3, you just create a bucket and you drop your files and you kind of move on. You don't really have to do a lot of like underlying infrastructure configuration and so on and so on. Same goes for some of the integration tools, like the API gateway that everybody uses when it comes to whether it's Lambda or some other application, to anything like SQS, which is your queuing technology. Those are all serverless. They're made to be serverless, where it's really transparent on what's happening underneath the environment. You as a customer only need to focus on your core applications, your business logic, and all that, and nothing else. You don't have to manage the operational aspects of it. So if you go to the next slide here, we'll talk about really the compute operational model here. And in this operational model, this kind of gives you an overview of where serverless kind of fits into the whole scale, right? And how it makes sense to use and things like that. So if you look at the bottom of the slide, this is your Amazon EC2. It's like infrastructure as a service. This is still old school. It's not like you're having your own data center, but it's still basically physical hardware software that's kind of dedicated to you, whether it's virtualized or not, that's a different story, but it's dedicated to you. You're responsible for the operating system and every single piece of code that's on there, right? So that's kind of aspect of it. But then when you go up this operational model, you go into essentially EKS, ECS, your Docker containerized workloads, where you're still managing your code, you're doing integration, you're managing your clusters. You no longer need to kind of you still have to manage your operating system in most cases, but you don't have to kind of manage any kind of orchestration or controllers, things like that. Then you move further up. That's where things get a little bit more serverless, where you're not managing the infrastructure at all. You don't even know what underlying operating system this platform is running. Of course, in most cases, it tend to be Linux, but you don't have to worry about that. You don't have to worry about configuring it. You only really need to focus on your application code and how do you want to secure and communicate with it. And of course, then we move at the top of the list, which is essentially the Lambdas, where you're really dealing with only your application code and maybe a couple of configuration options to see, how much memory you're going to give here and there. But that's about it. You don't have to manage any kind of infrastructure. You don't have to manage any kind of web servers or applications that don't directly contribute to your application itself. So having said that, let's take a look at the next slide here. Why are customers really, or why and how are customers really adopting the serverless strategy? And really, it talks about, building new innovations. And there are kind of 3 steps on this journey. First is reduce. And when we talk about reduce, we talk about retiring your old code, that's no longer in need or no longer used, as well as modernized in a sense where if you have an application or a third-party solution that an ISV provides a basically a SaaS offering, you take advantage of that. You move that workload from your on-premises application to the SaaS environment, and I'll take Splunk as an example, where a lot of organizations have Splunk on premises. Now, a lot of the customers to move to the kind of a cloud model, they're moving actually Splunk to the SaaS model, which the Splunk has offered. So it's kind of a neat plugin there, but that's the idea behind it. The second is really migrate to AWS. This could be simple as lift and shift. You have applications that you don't want to kind of touch. You just want to move it. It goes back to the standard old EC2 kind of and virtualization model, where you just want to move your application and run in AWS, and eventually either shut down your data center or just get rid of this old hardware that you are kind of running it on. And the last step is where things get really interesting. That's where you modernize. Once you have your applications on AWS, you take the time to re-platform them, whether it's kind of moving from one technology to another, to really refactor them if you don't need them, or you need to kind of modernize them, like let's say make them into a Lambda application, and so on and so on. So that's where things kind of come into the mix. So when we go to the next slide, we're going to talk about building new applications and what are the customers building, right? So this is an example of kind of a high-level example of what type of applications customers are building with serverless. You're talking about IT automations, you're talking about data processing applications, web application to machine learning. I would mention that as you go more and more complex, the Lambda mechanism gets a lot more complex. To be able to take advantage of machine learning, you really a mature level, whether it's web application and IT automation, you're kind of starting from the kind of the beginners, which we'll cover about that in a bit later. But these are just kind of touching the surface of what Lambda can do. At the same time, Lambda is not meant to run like long jobs and long applications. So there have been times where I've been kind of pulling into conversation where customers are trying to run batch jobs on Lambda, and which has been kind of an interesting use case to see, what they pull off, and they kind of struggle with the challenge. Hey, why is my Lambda function just stopping after a few minutes? Well, that's not what it was designed for. So we should be careful on how you use Lambda. It's not meant for every single use case. So definitely not long running applications or long running processes. It's not meant to do that. It's more designed for, if you have a request, usually in seconds or milliseconds. Of course, you can go up to a couple of minutes, quite a few minutes, but it's really designed to kind of handle a few seconds request or a request response kind of model as needed. And of course, you can kind of expand it because it's able to run for a couple of minutes as well for use case. So let's take a look at the next slide. What makes serverless work? Well, serverless is all about essentially loosely coupled architecture. It kind of goes much more closer to the microservices architecture. It's no longer about building monolithic applications where you have one giant application that does everything. In serverless, you're kind of building small pieces. You're integrating with different services to accomplish your task and goal, whatever that application does. So it just kind of gives you an idea of this on the architecture on the right here. It talks about, you basically, you have front applications, front end applications calling the APIs to get response here and there. But every single step is a smaller step in a larger processing request. You may not have in a kind of a monolithic, your one application would do everything. In this case, you have little steps along the way to make different steps happen and kind of complete the request. So taking a look at next slide, we're going to really talk about what is really connecting everything together. And that's really the events, and which are kind of the tissue that join serverless applications. So taking a look at next slide, serverless tends to be an event-driven architecture. And it really is important to drive reliability and scalability. It acts as an event router to kind of keep route what your requests are and where they need to go. Most of the requests tend to be asynchronous. Of course, with serverless as well as through other technologies, you can make most of your requests synchronous as well, but you just have to worry about the actual execution timeouts and things like that, but meant to be asynchronous. And eventually, of course, you can do event stores such as SQS to kind of queue up your request and kind of process them as you're able to and kind of run your business logic as you see fit. But it's really an event-driven architecture meant to scale very powerful and at very large scale, so you don't have to worry about configuring every single component and working from there. So when we take a look at next slide, we're talking all about decoupling. And that's really important because you want to decouple your application from the server that it runs on. And by doing so, you're actually increasing resiliency as well as you're able to handle error use cases a lot better. So what I mean by that is really in traditional application architecture, most of the servers are associated with your application. Your application is running on a specific set of servers, and that's what it's running on. And most of the time, you end up having sticky sessions of some sort where your quest and everything is managed by that server from all the way through the life cycle of that request. In the serverless, that may not be the case. When you make a first request, your application makes a first request, it may get processed by a different set of servers than the second set of requests, and it's totally randomized from that perspective. The idea behind that is really, if a server fails, that doesn't mean everything fails. It may just fail for that request, but the next request that comes in, it's perfectly fine. You're kind of decoupling that as well. So when we look at it, the next slide real quick here, we're going to talk about kind of a couple of things that AWS provide that really kind of manage and help you orchestrate a complex distributed workflow. And we're talking about here essentially step functions. In most cases, you want to build a bunch of application, and before step functions came out, you had a situation where people had built a lot of a lot of applications, a lot of Lambda applications, and they were tied essentially through like one Lambda calling another. And it kind of got really complex because it got to a point where you had streams of Lambdas, like one connecting another, and people lost track of which Lambda was talking to which space. So step function came out where it actually helps you define a very complex workflow. And you can basically say, hey, at the start of my application, I have 1, 2, or 3 different steps that 3 different Lambda functions go. And depending on the result of the request, I can go take a different path and kind of perform different activity. And you can make really complex architecture. On the diagram in this slide, kind of gives you a very simple overview of what that could be. However, you can kind of make really complex architecture and function flow. And beauty of it, it's mutable in a sense where, let's say today you have that, tomorrow you want to add another step or another action, you can add that action without having to refactor your whole application. So that's pretty neat there as well. So you can kind of enhance it and kind of scale it as you need. So moving on to the next slide here. We're going to talk about replatforming the application and how do we go about doing that. Well, we're going to talk about 2 different ways to do this. There's a lot of options available, but in the focus of serverless, we have 2 options right now that kind of makes the most sense. One is AWS Lambda support container images. Right. In the past, that was not there, but now you can actually take your container images and deploy it on Lambda. So you can essentially take your Docker image and say, hey, I want to, it's maybe a simple web application with request and response. I want to deploy it in a Docker container and kind of have it done. And I don't want to recode or even convert my application from Docker containerized application to Lambda. Helps you do that, helps you in some cases also remain kind of a cloud neutral, especially if you're worried about, hey, I want to be able to remain on, Docker containers because I can port them over to any place. But even regardless of that, you can kind of port your existing on-premises containerized application into Lambda and kind of run there. It's amazing in a sense on how well it integrates with a lot of the AWS services, and it's it's same billing model as if you were using Lambda. So you're not worried about running containers all the time and making sure of that. As a request comes up, more additional containers get spun up behind the scenes. You don't even have to worry about that and kind of go from there. And the next item we're going to talk about, which is on the next slide here, is really Lambda extensions. They are, Corey is going to talk about this in a lot more detail than I am, and kind of even show you how they kind of play out. However, Lambda extensions were introduced in a way to kind of keep track of what your core function, your core application is doing. And beauty of this is you can have your core business logic do what it's supposed to be doing, and then you have your extensions, which is kind of runs behind the scenes, and it can do anything like monitoring to observability activities, to even do some of the logging actions, and so on and so on, and all so that you can kind of separate the roles of your Lambda function even more than what they are now, and your application developer or anybody who's doing the development can focus on core business logic and less of how do we keep logging going, how do we keep performance in check, and so on and so on. So that's very important to be able to kind of re-platform and kind of deliver kind of the monitoring capabilities that new kind of compliance frameworks keep adding on to it as well. So when we go to the next slide, we're going to talk about what about refactoring the application and how do we go about doing it. So on next slide, we kind of take a look at a traditional 3-tier application. In a common 3-tier application, most of the time people make this into a 2-tier application, but a 3-tier application, you have your web servers, which is your presentation layer. Then you have your application servers, which is hosting your business logic. And then you have your database servers, which is essentially housing your data layer. Now the question becomes, how does that translate? How do we refactor that into serverless? Well, the answer is in the next slide. It's all about taking that 3-tier application and kind of re-architecting it. And we do that, we kind of break the barriers here. Now we're no longer connected from server to server. We're kind of tied through events as well as through APIs, and it's kind of start to merge together. But from the point of view of from this way, your presentation layer is essentially your browser, or maybe there may be a Lambda aspect of it, but in most cases your presentation becomes your browser, and then your business logic is behind the scenes, your Lambda, your step functions, and so on. And then of course you have your data layer, which is kind of either interacting through messages, queues, or even kind of serverless databases such as DynamoDB, which is storing your data. And of course, you can use traditional databases and the RDS service to kind of help you manage all of that, or use the serverless option as well. And that's how it will translate into a traditional 3-tier application into the serverless model. So going forward, if you look at the next slide, key things we want to talk about is speed, simplicity, and delivery. When it comes to talk about serverless, those are the key things that really matter, right? So we want to be able to be very quick, be able to as well as code quickly, as well as run your solution very quickly and efficiently, as well as keep it simple. The old adage is keep it simple, stupid kind of thing, where the more simple you do it, the more adoption you have, much easier it is for people to use. And then of course to deliver, you want to be able to deliver production ready code. It's great that people love to code. Then in a traditional manner, you may have months of development time just to produce one single application. In the case of Lambda, you may have your first proof of concept ready within like a week or two maximum, and then you just do iteration on top of it to be able to deliver a full scale application. So that's kind of the key tenets that you want to kind of think about and talk about. So taking a look at the next slide here, we're going to talk about the adoption pattern a little bit. So earlier we talked about different type of ways the Lambda can be used, whether it's IT automation, things like that. Well, this kind of diagram kind of shows where you are in the life cycle. You can kind of consume this diagram in many different ways, but if you look at kind of the bottom axis and basically the x-axis and the y-axis, you're looking at the type of activity you're doing as well as the Lambda usage. the beginner's phase or the early phases of Lambda adoption kind of goes around basic activities such as log processing, doing cron jobs and things like that, just to trigger events and doing small activity. Then you get into your data transformation layer, and that may be you're getting a piece of set of data from one application to another. You need to kind of do some modification, or maybe it's even some sort of ETL activity, and kind of transform it and store it in a different format. A very common example that people tend to use is you want to kind of remove some sort of or you want to add some sort of a watermark as part of your images. So you can use Lambda to do that. It's relatively simple and straightforward, and then kind of do that data transformation. And then of course then you go into the microservices. That's where you're at kind of very peak of your kind of adoption, where you kind of innovating beyond what you realize. But at the data transformation kind of path, that's where in most cases you kind of become mature. You're no longer beginner, but you're no longer advanced either. You're kind of somewhere in the middle. You're mature. You're able to have production ready, mission critical application kind of take advantage of Lambda and deliver. And the last slide I will be talking about is on the next area is serverless is all about innovation. We talked about this a little bit. We want to increase agility. We want to be able to kind of deliver new toolings, new applications relatively quick. We want to be able to perform. We don't want people to worry about, is my application going to load when I have high stress coming around? You don't have to worry about it. And of course, high value is very important as well, because we want to be really cost perspective. When we're talking about billing perspective, we're talking 1 millisecond billing. So as per that is you're going to get billed. And in many aspects, you also have the free tier with serverless coming to the mix. I've known customers who have not utilized, not even gone beyond their free tier and still able to use AWS for almost free. Except for something like S3 charges here and there for their storage, but they're using Lambda essentially for free for their production workloads. And then of course we have a huge portfolio of services that integrate with Lambda to kind of make it possible for you to do almost anything you can even imagine. So, excuse me. With that said, I'm going to pass it on to Corey, who's actually going to dive deeper into some of the serverless aspects, as well as kind of talk more about the Splunk observability space.
Thank you very much, Ashneet. Thank you. That was very insightful. All right, so let's go over operating serverless and what some of the challenges that we might face, and really how we go about observability in these serverless environments. Now, computing has gone a long way from what we knew, right? So it started off what we all had, some time ago, which was the physical machines. It required a lot of guest planning at the actual capacity that we needed. It would live on premises for years. It required heavy investments into CapEx, and it really brought down our cycle. So the innovation factor was a lot lower, right? So you deploy in hardware in months. It would take quite a long time. Because of the time that it would take and how long it lived on premises for, you could talk maybe 6 months or more, and really only doing it a couple of times a year. So it was really slow going and minimized our innovation. Right, and then we moved into virtual machines. So here we started to introduce hardware independence. We increased our provisioning speed down to minutes and hours, and that was really significant. Able to trade some of the CapEx for OpEx. We're able to get more scale, so being able to provision multiple VMs per server rather than having a one-to-one. It gave us the ability to introduce elastic resources, really increased our speed and agility, and reduced the overall maintenance as well. Right? Leveraging some hypervisor tools, so on and so forth, really gave us an extra tool, an extra capability that we could leverage. Right? Now, a few years ago, we had an amazing paradigm shift to containerization. Right? Containers are everywhere at the moment. And what this gave us was a lot of platform independence, right? That portability is what gives us that platform independence. It gave us a consistent runtime environment. We got even higher resource utilization, being able to provision more and more containers into that particular server. It gave us easier and faster deployments. We got that isolation and sandboxing that gives us that security. And the start speed, right? We're now talking a matter of seconds to deploy. So now we're evolving into serverless, and this is where we see things like Lambda and Fargate. And what we get from this is continuous scaling, which AWS is managing. We've got fault tolerance built in, and the focus on what we're paying for has also shifted. So we're no longer just paying for and maintaining hardware, and when we're not using it, basically paying for it to collect dust. We're paying for that utilization. We're paying for what we use. We're paying for the compute that's being triggered. And of course, there's no maintenance. So AWS very kindly takes care of all of that for us as well. Because of how accessible it is, this is why Gartner estimates that organizations, at least 75% of organizations, are either using or planning to use serverless functions. And you can see a bunch of reasons why this is the case. Now, if this is true, and serverless provides all these amazing benefits, then you might ask, well, why isn't every use case or workload now serverless? That's a fair question. It's because there are challenges that come with using serverless operations. Now, while Lambda enables companies to increase the pace of software innovation and control costs, it also presents its own set of monitoring and observability challenges. What we'd all be familiar with, the agent-based approach, it no longer works. Now, since serverless separates code from the infrastructure running it, agents can't be installed to collect and transmit observability data. Now, unless you're using the Splunk Lambda extension, and we'll go into this a bit more later on, there's no place to batch the data either. So traditional monitoring tools that use a batch and query architecture doesn't work in these serverless environments. And they're not designed for streaming data analytics. So using them in a serverless environment will result in drop data points, and as a result, hit our analytics accuracy as well. Now, scraping metrics from CloudWatch at a typical 5-minute resolution can result in slow insights. And if we try to poll them too frequently, we might consume our AWS API limits. So how do we solve some of these challenges? Well, I'm very happy to introduce Splunk Infrastructure Monitoring. It's part of our Observability Cloud suite. And what we focus on here is really, it's a solution for on-premise, hybrid, multi-cloud monitoring. Right? It covers Linux, Windows, VMware, and the major public clouds. And AWS, of course, is one of them. It's purpose-built for ephemeral and dynamic environments such as Kubernetes, containers, and serverless. And look, it not only gives you insights about your Kubernetes clusters, it can also automatically discover services you might be running in these environments. And think services like Redis, Kafka, Cassandra, MongoDB, Nginx, and there's hundreds more as well. We get analytics-driven accurate alerting, and there's over 200 plus pre-built integrations that you get for immediate visibility and data ingestion as well. Now, if we go back to Lambdas for a moment and how we'd like to use Splunk Infrastructure Monitoring to get visibility of the performance metrics of our serverless functions, this is where those Lambda extensions come into play. So Splunk solutions enable DevOps teams to easily understand the performance usage and the bottlenecks across our entire application spectrum. So whether your applications consist 100% of serverless or a bit of a mix of serverless and traditional, you can monitor your entire cloud stack with Splunk in real time. And the key features here is that we support any language and any runtime. We've got automatic data collection without developers having to instrument code. And we can monitor key business performance metrics in real time using function wrappers as well. So let's dig a bit deeper into Lambda extensions. Now, extensions extend the Lambda invocation cycle. And the key thing is here that they only run when there's something to do. And importantly, they're not running and they're not executing when there's no task to complete. They can also continue to run after a function invocation has finished to be able to send that telemetry data out about what happened during that function invocation. Now, extensions that run within the execution environment, but outside the runtime, can start before the runtime process and can continue after the runtime shuts down. Now, because extensions run as their own processes, they can be written in a different language than what you've used for your actual function. Now, this is big because you may choose to write your applications in any supported runtime, be it Java, .NET, Node, Python, Go. And at Splunk, we've written a serverless extension for AWS Lambda that can work in any environment that you're running. Next question you might have is, what are some of the implications of running this kind of Lambda extension? Now, there are a couple that we need considerations that we need to factor in. So it needs to be compatible with the same compute environment as the function itself, as it's sharing the same resources, CPU, mem, disk, etc. Secondly, whatever the IAM role for the function has access to, so does the extension. And similarly, whatever access the extension will need, you'll need to give it to the function IAM role as well. You can have up to 10 extensions per function, and the size of the extensions counts towards your deployment package limit as well. So just a few considerations there. Now, what kind of performance implications might we see running Lambda extensions? Well, it can impact performance because it is leveraging those same resources, right? CPU, mem, temp disk, so on and so forth. Now, if an extension is performing compute-intensive operation, we can potentially see our function execution duration increase as a result. Also, as the extension is initialized before the runtime process starts, it must finish initializing before Lambda invokes the function. And so that can also contribute to latency. Now, if more resources are needed, however, we need to scale it up, then we can increase the memory, which will also proportionally add additional CPU and network throughput. During the function, all extensions must complete within the configured timeout setting. Otherwise, the actual function itself will time out as well. So just another key consideration there. So let's look at some of the performance metrics that we might actually want to monitor for our serverless functions. So when you invoke a Lambda function, the request is processed in a container environment. When a function has not been executed for some time, or when you need to process more concurrent requests, AWS Lambda will start a new environment to execute your functions. Now, the initialization of the runtime of your code leads to additional latency. This kind of latency is usually referred to as a cold start. And if you have several Lambda function invocations in a chain, these latencies can add up and result in a poor user experience. In fact, a study conducted by Akamai showed that every 100 millisecond delay in a website load time can hurt conversion rates by 7%. So this is key. Now, since Lambda functions are billed by duration in milliseconds as well, your AWS costs can also easily build up if you're not managing your latencies. And this is why real-time visibility into latency is required to manage costs as well as deliver that flawless user experience. So cold starts are a big one. Then we can look at things like durations, throttles, concurrency, how many functions can be executed in parallel, for example, invocations, errors. And errors can be because of the Lambda execution environment or your code throwing exception. And we can use Splunk infrastructure monitoring to measure and track all of these performance metrics. The Splunk extension for AWS Lambda has two modes of getting data in. We've got fast ingest and buffering, as I mentioned earlier. So fast ingest is really for the functions that are infrequently used, and that'll get metrics into Splunk infrastructure monitoring in the fastest way possible. Where time sensitivity isn't too critical, we can also use the buffering option. Now, there's a couple of metrics that we can't get through the extensions that have to come through CloudWatch, and that'll be metrics like provision concurrency and spillover of provision concurrency. And this is where we use metric streams for near real-time data ingest. And then we think about also the business metrics to support our insights and our observability. All right, so for example, you might want to know how many orders did we process per function invocation. Now, for these use cases, Lambda wrappers can be used as a Lambda layer in your function to send all the metrics and dimensions you like to Splunk infrastructure monitoring as well. So these aren't operational telemetry data. It's about the metrics you've defined about your business or any custom insights you're trying to put together. Now I'd like to talk to you about why we use Splunk. Now, we touched on this earlier. Traditional approaches to monitoring don't work in cloud environments, right? Traditionally, tools typically store metrics data into a time series database, and they have a separate system for alerting, analytics, visualization, automation, and data science. Now, all these components periodically poll that TSDB to update their state. And this batch and query architecture doesn't scale and is not fast enough in the cloud world where data volumes can really explode and complexities can also really explode. So competitive solutions typically use this approach because they were designed in pre-serverless world. but we take a different approach at Splunk. So we talk about with Splunk infrastructure monitoring and really the whole observability cloud suite. We focus very much on a streaming-based architecture, and we've optimized it from the ground up for real-time behavior. Now, why? Ultimately, monitoring is not about putting up pretty charts on the wall TV. It's about putting yourself in a position where you can anticipate problems. And monitoring should be about interactive visualization, using data to explore and query and understand your system. We'll want zero lag alerting. You don't want any unnecessary delays getting in between you and the information you need to know, especially when things are abnormal or even trending that way. And we want a live data feed. If we want to start to explore automation, we need insights that we can trust, that are up to date and that are accurate. We can't wait for batch processing to deliver late results. Now, how does this work? And we look at this slide from left to right. We've got several patented innovations in how Splunk can deliver on this promise of real time. But the essence of what we're doing is streaming all the way through to the system. So first we separate the metadata and the data values from right at the front door. This also lets us scale these separate systems independently when we're trying to support different classes of data. Secondly, we do work dynamically to adjust for any sort of jitter and lag due to any sort of system or network that we have within our application stack to make sure that our analytics is accurate. We're also automatically rolling up these metrics as the data comes in. And that may be for example, 1 minute, 5 minutes, an hour, and so on and so forth. So that data is also readily available. We're not going back and trying to process and aggregate that data when we need it. Thirdly, we put all the data into persistent data stores, but we optimize it as well so that retrieval times of historic data can be used in analytics and visualization just as quickly as our live data can as well. And last, we have an analytics engine that's subscribed to the live data streams that it needs, and it can process that data in small chunks to deliver those real-time, low-latency charts and alerts. Now, without further ado, let's see the product in action. So I'll just pivot over to a demo. One moment. Hopefully everyone can still see my screen. Just before we kick off into the product itself, I thought I'd just touch on the metric streams that I mentioned earlier as well. So it leverages a Kinesis fire hose there so that we've got a very low latency data ingestion mechanism. And there's also a cloud formation template available. You can deploy those per region, and that'll get you up and running to be able to stream that data right into Splunk infrastructure monitoring. Okay, so onto the tool. So this is our observability cloud product, and you can see here there's a number of different tiles, but the one we're focusing on today is in the infrastructure space, right? And Splunk infrastructure monitoring is not just about Lambdas. In fact, we can cover all your AWS services, right? So for example, if I hop in here to EC2s, and you can see we've got over 4,000 of them. We've got a very performant, quick way of analyzing our entire EC2 fleet. And you can see just how quickly this data loads as well, right? We can split this data by CPU utilization, disk, network. We can then start to group. Maybe I want to see it by availability zone, for example. And you can see the immediacy of how quickly it will splice and dice this data for us. And I might also want to look for outliers, right? So some of these yellows that we're seeing, CPU utilization, if we compare them to historical trends, we might want to get a bit of a view of, is this an anomaly or is this historically being this way? And again, these analytics, as fast as they are, because of that real-time streaming architecture that we have. There's a whole bunch of other metrics we can see from here as well. Of course, the number of hosts, the overall CPU, memory, disk, so on and so forth. But you can see just how quick it is. What I'll do is I'll go back now and let's dig into the Lambdas themselves. So we'll hop over into Lambdas. And again, you can see just the immediacy of how quickly this data is loading. And similarly, that tagging, that metadata that we have for our data, I can use that to splice and dice this into something that's meaningful to us, right? So if I want to split this by, say, for example, account ID or region, wherever it may be. So for example, I'll just go by region. Very quickly, we get a breakdown of our functions by region. And then we've got here the overall summary of our functions. So how many functions have been triggered over the last 5 minutes, functions by AWS account, by region. We can look at total invocations. Here we can see invocations as well as any sort of errors and throttling. We can get a view of total errors, and we've got a heat map here to very quickly show us where we're seeing issues within our Lambdas as well. We can split that out. We can have a look at how each particular function is trending when it comes to things like errors. We get a view of percentages. We can look for the average duration, and we can look at that across all of our functions, or even down to a per function basis as well. And of course, being some functions just naturally take longer. They may have more work to do, more work to compute, in which case any sort of thresholding would be dynamically applied to each particular function due to the nature of the function itself. And then importantly, also, we've got a view of some of those metrics we touched on earlier, things like throttles. We can see a throttle heat map here, as well as by function and any sort of provision concurrency spillover as well. Now, the other key thing is once we've got this data into Splunk infrastructure monitoring, as I mentioned, we've got other services in here from AWS. Being able to tie this all together and paint that clearer picture is really how we can turn this data into something really meaningful and impactful. So getting a view of your entire application stack, everything you're running in AWS, and correlating it all and stitching it together is really how we can get as much value, as much impact, and minimize as much troubleshooting as possible within our environment. So that's, I think, all the content I had for today. We've also got some resources available for everybody. There's some free training. There's also a free trial if anyone would like to spin up an instance and have a look. There's no credit card required or anything like that, so go ahead and spin one up. We've got a few links here to some blogs and docs that you might be interested in, as well as a GitHub repository for the Lambda layer itself, and a bit of an ebook that we can have a look at in your spare time. I think that brings us to any Q&A, if there are any questions.
Thanks a lot, Corey, for a very insightful session. So I'm sure the audience would have deep dived and learned a lot about serverless architecture and the serverless journey, along with the challenges in operating serverless applications. And specifically, I think that demo was really useful of how to use Splunk's AWS Lambda extension to monitor, manage, and optimize the performance at the cost of your serverless applications. So with that note, we do have some of the questions, and I will just publish the first question, which is there as part of it. So the first question states as, does serverless applications make sense for small businesses?
I think this is a great one for Ashneet.
Yeah, so I'll take that on. So serverless is extremely ideal and for small businesses, especially when you're talking greenfield, right? So when new customers come on board, or they may have set of developers, they don't want to incur cost of having set of servers that's always running. Which can be really expensive for small businesses, because for a small business, say $100 to $200 a month charge may be a lot just to kind of keep servers running, and especially then on top of that you have to manage servers, any kind of updates, you have to worry about any kind of security issues. That's a lot of work for a small business, and they may not be equipped to handle that. With serverless, that is all of that, most of that's gone. You just need to have a developer that's working on actually coding the application. Everything else is kind of more or less taken care of. And as you kind of grow, your business grows, the serverless grows. And of course, with the way serverless is set up with free tier, in most cases, many small businesses are free, using the service for free for a very long period of time until their application exceeds that. And even after that, they maybe pay pennies on the dollars to kind of keep their applications running. So yeah, so ideal for small businesses for sure.
And you really just get that shift, that we touched on it earlier, that shift of really the frame set of, rather than paying for hardware and trying to justify the value you're getting from it, right?
Yep.
You shift to a model where you're only paying for the value that you're getting out of something, right? So if it's not being used, you're not paying for it. And really when you're, especially if you are a small business, then you probably don't have the luxury of being able to splash out for a giant data center, of course, right? So
Yep.
this kind of thing really makes sense for small businesses as well. Great
Thanks a
question.
lot.
Thank you.
All right, cool.
Yeah, Corey and Ashneet for answering that. So before I move to the next question, I will also reopen the poll because there has been some new audience which has joined in after the session was started. So hopefully we can also get the mix of overall audience now. So I'll just launch the polls once again.
Yeah, it will be
Right.
great to see who we've got in the audience today. I'm always
Correct.
fascinated
Yeah.
to see who's
So
coming along.
we'll
Yeah.
keep, yeah. So we'll keep the poll open while we answer the questions, and then at the end of the Q&A, can look at the overall poll answers. But the next question I have, Corey and Ashneet, is what about logs? How do we get logs from the function to Splunk?
It's a great question. So the logging from your function will go into CloudWatch. And then using those metric streams that we touched on earlier, we can actually get logging streamed in near real time to our Splunk product as well. And so one of the tools within the suite is Log Observer, and that lets us correlate and stitch particular functions and any sort of requests within our application directly through to the relevant logging that was involved in that request as well. So, we've already got those metric streams set up for some of those key metrics around provision concurrency, and we'll use that same template to be able to pump logs in as well.
Awesome. Thanks for answering that again, Corey. And I would also like to divert the attention of the audience towards the handouts as well, because there are some really insightful handouts which are available, and you can simply toggle into the handout section and can access and download those handouts to read it later on as well. So now moving to the last and final question is, can Splunk monitor and generate alerts on timeouts and or packets drops between processes or even containers speaking each other?
Great question. So with Splunk infrastructure monitoring, we can obviously look at the network performance of each particular instance, whether it's an EC2 or a container, whatever it may be. We can get the network performance of that particular instance. But when we start to talk about communication between instances, between servers, between containers, then we more move into a network performance monitoring tool. It's a bit of a different use case, but what I can say is a bit of a spoiler for those that are interested in Splunk Conf, which we've got coming up very soon as well. We've got a sneak peek of a brand new capability we've got coming into the observability space exactly for this. So keep your eyes peeled. We've got a network performance monitoring tool coming right in, and that's going to give us a great service-oriented network performance capability. So I'm very excited for that. But yes, definitely keep your eyes peeled. It's coming.
Awesome. That sounds really exciting, Corey. So I think that kind of covers the Q&A which we had. And I've also closed the poll. And I think, Ashneet, your wish for having an architect has really answered, because we do have an architect as part of the audience. So I think definitely a good mix. And I'm sure there has been security analyst as well, probably too shy to mention or too secure to mention over here, but I'm sure they are part of the audience, and the audience who would be watching the session later on demand as well. So before we conclude the webinar, any final thoughts or takeaways, Corey and Ashneet, you would like to share?
I guess one thing would be just that it's never too early to start on your observability journey. Getting observability part of your environment is really going to help you to gain that developer velocity. Is going to help you to scale out and leverage more and more of these amazing cloud technologies, both quickly and as reliably as possible as well, right? So it's not just a matter of are we looking for outages, right? We want to look for where we can improve, where can we get more performance, and how can we save on costs. And getting that visibility into what's happening in the cloud space As you can imagine and appreciate, there's a lot of different services offered by AWS, and it can be quite complex sometimes, managing all these services together. And so we're really, bringing that all together and simplifying how we can view what's happening in that space will give us a good control over really getting started and up and running with cloud.
Yeah, and just to add on to what Corey said, as he said, it's never too late to get started, especially if you're starting just now on the journey. Think about observability as part of your serverless architecture as well. A lot of the time, what ends up happening is customers start saying, hey, I don't need to worry about observability and things like that. And they build these complex applications on Lambda and so on. And then eventually they're like, okay, I some sort of a organization or some sort of a security team's like, oh, we need to implement all of this. And now they have a huge backlog or technical debt that they have to kind of go back and refactor a lot of things. Luckily, the observability suite makes it a little easier, but that's still a lot of work that you have to go back. So if you were to start off with that mindset to begin with, you have a less of a hassle later because it's kind of done for them, and anybody who needs to see that, they can see it, as well as you can monitor it yourself as well, which will help you see, things like uptime, things like, how is your application doing, and how is it performing in a general sense as well.
Awesome. Thanks again, Ashneet and Corey, for that insightful session and also answering those really great questions as well. So with that note, once again, this session will be available on demand. So you can also share with your colleagues and friends who would be interested to join in and learn by this interactive and insightful session. And with that note, this is Dheeraj Nayal, Global Community Ambassador at DevOps Institute, signing off now. Thank you so much.
Thank you, everyone.